Morning, everyone. So I just want to finish off this chapter on space travel. So we talked about the space race in our live class on Tuesday, and we talked about the difference between rockets and shuttles and the International Space Station and what goes on there. Briefly about the physics of how a rocket works, as in how does it take off. We had a discussion around telescopes, kind of more about the different types. So we have your light telescopes, and some of them use refraction or bending light. So they use lenses, and then some of them use reflection, or the bouncing of light, and they would use mirrors. And then we talked about the radio telescopes and the benefits of a radio telescope over a light telescope. So just moving into, I suppose, what like space and the future, it's what they're currently working on, and I suppose what they will continue to work on, and as technology improves, their investigations should improve. So just briefly, the space missions here. So there are four types of space mission. So we have human missions, where they land on an object to study it carefully. So that would be like Neil Armstrong landing on the moon. So they would gather rocks and gravel and anything that they can find and bring it back to Earth so that it can be analysed. Obviously, just being there for a certain amount of time and experiencing the difference in gravity and things like that. So they're specifically studying that object. You can have flyby missions. So we talked about some of these the other day, but flyby missions is where they send a craft past a planet or a moon or something to take pictures. And it's normally as part of another project that they're doing. So they're heading to Mars, and as they pass by a moon, they might take some pictures and sort of investigating on their way to something else. Orbiter missions. So the clue is in the name, where they circle around a planet or a moon to take detailed measurements of the body. So it's not just a drive-by, kind of a flyby, that they're actually going around and around and taking measurements and pictures and things of all different sides of the object. And then your robotic lander. So this would be like the Mars rover. So this is where they launch them and they actually land on an object. So they land a spacecraft in a location that has been mapped out by the orbiter, and then the robot then can go around and gather data and take pictures and things like that can be fed back to Earth. Okay, so there are your kind of four types. And all of these are happening already. So if you do a little bit of Googling, you'll be able to find out kind of the most up-to-date information about different ongoing projects. And then presumably, like that, as technology improves, they might be able to improve the robots that they're sending, or improve the crafts that are passing by and taking pictures, things like that. Space tourism, you've probably heard about this, that they're Virgin. So Virgin, they have a fleet of airplanes. What's his name? Richard Branson owns Virgin, and they have a load of airplanes, and he is trying to organise basically a flight into space, but it would be commercial. So it would be like booking a seat on a plane, but you're booking a seat on a space shuttle and launching into space. And you wouldn't land on anything, but you would fly up into space and just pay for a ticket to fly up there and come back. So this is something for the future. I mean, it is happening now, in terms of that it's been talked about probably for the last 8 or 10 years, but it hasn't actually happened. The search for other life is an ongoing thing. So they do it in a number of ways. They analyse the meteorites. So we talked about meteors before, and when they strike the ground, the Earth's surface, they're called meteorites, and they analyse them, and they're looking for, I suppose, evidence of life, so things like fossils or bacteria. And the robots that they send, like the Mars rover, that they send up to explore the planets, a lot of the time what they're looking for is liquid water. So for life, and it says it there, as we know it, for life as we know it to exist, there needs to be liquid water. Now, not to say there isn't other types of life out there. I mean, there's no proof that there is or there isn't, but I suppose the kind of life we're looking for is the life that we're used to. So we're looking for like bacteria or like very, very small microorganisms. Um, so liquid water must be present for that. And then the radio telescopes that we talked about the last day. So they listen to the radio telescopes for any kind of communication from other civilizations, or trying to make contact, I suppose. It's actually called the search for extraterrestrial intelligence. So again, if you look into this any further, I've heard some things, silly little talks on the radio or whatever, but where they are doing this, like they send out messages in all these different types of using Morse code, or using different types of, because they don't, obviously there's no point in just speaking English or speaking Chinese or there's no point in doing that because we don't know what they speak. So it's trying to send out some kind of a communication that will be received no matter what method of communication those other civilizations use. But this again is an ongoing thing. There are people who work in this department trying to make contact with extraterrestrial intelligence. So again, not so much the future as now, but again, you would imagine that as technology improves and they can send these probes further into space, God only knows. So the last bit here is benefits of space exploration and hazards of space exploration. This is quite important. This is actually specifically in the specification. So you need to be able to talk about these. Now, these are not, I was going to say they're not rocket science, but they're literally, these. I mean, if they ask you for the benefits of space exploration, you could probably come up with a few, okay? So these don't need to be learned like verbatim. You just need to know them. So the main benefit of space exploration is the new technology. So what happens is they develop things for rockets or robots or spacecrafts or whatever it is, and then the technology that they use initially in a spacecraft then ends up kind of filtering down, and they're used in daily life. So you'll see, I used to watch a lot of Top Gear, that it's that program about cars, and when they look at like the absolute top end cars, they'll have a bit of technology and they'll be like, this was originally used on the NASA spacecraft that was launched in whatever year, like that they started their life as being developed for space travel and then they end up filtering down. A good example is GPS. The breast cancer test imaging, so the way that they scan, it's called a mammogram, the way that they scan for breast cancer. The scanning process was something that was originally developed, I think it was by NASA, and used for those flybys and taking pictures and things like that. So there's other ones there, portable scanners used to diagnose diseases in Africa. And then talking here about, I think I mentioned this the other day, you're learning more about the Earth's atmosphere and how to predict weather and natural disasters. And so there's a lot of work on the International Space Station going on around that. So all these are huge benefits to space travel and how they filter down into, and I'm sure if you did a little Google on the benefits of space travel, you find loads of little things, like things that you use even around your house that were originally designed, because a lot of the kind of tricky little gadgets and stuff that you have that make life a little bit easier, a lot of them were developed for space travel. Hazards, I mean, again, you could probably come up with this, but major hazard is that it's dangerous to go to space. So lots of accidents have happened and astronauts have died. Especially in those early missions, the earlier missions, I suppose they have gotten better, but I mean, it's still massively risky. Anything that goes wrong, you're, the hundreds of thousands of miles, kilometers away. anything that goes wrong, I mean, you have to be able to attempt to fix it yourself. And if it's something that's unfixable, you can't drive it to your local garage and get it fixed. So it's still an incredibly dangerous thing to do. And so we talked a bit about this. Missions can expose astronauts to a wide range of health problems. We talked about we specifically there talked about the skeletal problems, the problems with the bone density. It has an issue on the cardiovascular health as well. Exposure to high energy cosmic rays. So we were talking about waves the other day. Cosmic rays would be in that band. So they're waves carrying energy, and they can lead to the development of cancer. So, all these issues that you go into space, spend a bit of time there, particularly the International Space Station and stuff like that, it can have long-term effects. Space missions can leave behind debris and junk. This is the picture I was talking about. Did I come down to this? This picture here, all those little white spots, see them all around? They're all space junk, essentially. So they're like satellites and rocket launch boosters. Like those earlier missions where a lot of those things weren't being returned back to Earth. They're just there, and they've been held in orbit by the Earth's gravity, and they just stay there. But it makes when you're trying to launch another rocket quite dangerous, because if they have an impact with a pretty large piece of space junk, it could be knocked off track, or knock a vital piece of equipment off a spacecraft or whatever. So it's quite hazardous having all of this space debris just sitting there. It says down here 95, see it down here, 95% of the objects denoted in the diagram are debris, discarded boosters, or non-functional satellites in low Earth orbit. So almost all of that it's essentially been dumped there by humans, which, that's what we do. The last thing here we definitely talked about. So in the microgravity environment of space, astronauts lose on average 1 to 2% of their bone mineral density every month. On the long duration space missions, bone loss can be serious unless astronauts take suitable exercise. So I think we talked about that. I showed you this picture already. This is them struggling to stand up because the way they feel the Earth's gravity is much stronger, because they're used to the gravity in the ISS. I remember doing this calculation years ago about what the gravity is on the International Space Station. It's not as low as it is on the moon, but it's lower obviously than it is on Earth. So when they return, because of this lower bone density, they can be at risk. I remember I told you I went to a talk in DCU with an astronaut who'd been on the International Space Station. He was saying that he came home, and he was home like, I don't know, a couple of weeks or whatever, and he'd been cleared by doctors and everything. And his son threw him like an American football, and he caught the American football and he fractured both his wrists in catching it. So things like that, because his bones were so weak, they literally just broke, and he ended up in a cast for 8 weeks with both his wrists. That was just a little story he told. But yeah, so that's it. Take your notes down on that, please. The 4 types of missions, the space tourism, it's like, I suppose it's more just to know it. And the search for other life, again, just to know it, that they do continue that search. And benefits and hazards, you do need to know a couple of benefits and a couple of hazards, okay? But don't be taking down all these notes, like just a little highlighted section, so you have a couple of clip notes. So for homework for Tuesday, what I would like you to do is design a spacesuit. So, I mean, if you Google, elements of a spacesuit, you'll get the fact that they need certain things. But given you are not actually going to send someone into space in it, if there's any improvements you would like to make on the spacesuits that they currently send the astronauts into space in. So what do you think is required for the spacesuit? So I'd like you to it doesn't really, like, you know how bad at drawing I am. So if you're a talented artist, by all means, make it beautiful. If not, it doesn't need to be beautiful, but it needs to be labeled with things like helmet, so that they can breathe oxygen, oxygen pump to pump the oxygen in, oxygen tank, so everything has to have a label, as in what is it there for? Why is that there? Why is that there? Okay, so I'd like you to design a spacesuit, but make sure that it has labels describing what each part of the spacesuit is there for. So why every bit that you put in needs to be put in for a reason, and that is actually something that they struggle with in NASA all the time, because weight is so important. They can't have excess weight, so everything that goes into the astronaut suits, the spacecraft itself, anything that goes in has to have a purpose. Nothing is put in kind of willy-nilly. It all has to have a purpose. So it's the same for your spacesuit. You need to put absolutely everything in and tell me why it's there. Okay, so that homework is due for Tuesday. So have a good weekend, and I'll talk to you on Tuesday.